Hello everyone, my name is Leonid Startsov and I am from Kotlin libraries team at JetBrains. And today I want to introduce you a Kover, a new Kotlin code coverage tool. But first, let me remind you what is code coverage. Let's assume we have a main class which has three functions. One of them is world, which is an inline function that simply returns a string literal. Another one is greet, that accepts a string and returns hello this string. And the third one is hello world, which simply returns hello world using our inline function. And let's assume we want to write a test for this class. So we create a new instance of class main called m, and we call mGreet from mWorld and assert that the resulting string contains the word world. Question we should ask ourselves is, have we tested all functions in this class? Of course, if we look precisely, we can find out that we have called the world function and greet function, but we haven't called the hello world function. So we don't know whether it works correctly or not. To track such problems, we can use the code coverage tool. So the coverage tool is basically a tool which shows you which lines of your code have been executed during a test run. So it helps you to track problems such as functionality that hasn't been thoroughly tested, like in our example, we forgot to call the hello world function. And it also helps you to track edge cases and dead code, because it can also track whether your branch in your condition was executed or not, or some other problems related to conditions or loops. However, you should remember that coverage tools don't help you with writing a correct test or program, because if you wrote an incorrect test for the incorrect program, you might get 100% of coverage, but, well, they would still be incorrect. So let's now take a look at how does coverage tool work. So if we want to write our own coverage tool, our steps would be the following. So first, we should write a Java agent using instrumentation API. Instrumentation API is basically a Java API that allows you to take an compiled class, an existing bytecode, and modify it so it would do some other things than it was intended to do. Then we should load the agent into our JVM, where we want to run tests for our program. And then we should just modify every function in our program so it reports whether it has been executed or not. So it would not only do the thing we wrote it to do, but also it would report whether it has been called. So now, when we know how such tools usually work, we can answer a question: can we use existing tools with Kotlin code? And the answer is yes, of course, because Kotlin runs on a regular JVM, so we can use an existing Java tools for code coverage, because basically they modify bytecode, and a Kotlin code as well as Java code compiles to JVM bytecode. So we can try to use a well-known existing tool called JaCoCo. JaCoCo stands for Java Code Coverage. It is an existing tool, and it has a well-known and widely recognized report format. We can successfully launch it with Kotlin and collect some coverage. But we may notice that it has some quirks. In our example, it marked the greet function as covered, but it haven't marked the world fun as covered, because, well, it is an inline function, and in Kotlin code it has been inlined, and the actual function in bytecode has never been called. So we may conclude that we may use Java tools with Kotlin, but for some Kotlin-specific features, like inline functions, they require some additional work to do. Then we can try to use another existing tool called IntelliJ IDEA Coverage. It is basically an action that is available in IntelliJ IDEA that takes your tests and runs them with IntelliJ IDEA Coverage agent. It's available in the IDE, and it shows results in the IDE. And as we may notice, it handles Kotlin pretty well, because inline fun in this example is marked as green, which means it was covered during our test run. However, downside of this approach is that it is only an IDE action, so it is not available in the command line, and therefore you can't launch it on your CI server. It also reports coverage directly in the IDE in the form of these covered lines, so you can't export its report somewhere else to analyze it. We need also to factor in Kotlin multi-platform projects with multi-platform programming. Multi-platform projects usually have different file structure from regular Kotlin JVM projects. So to configure our tools, we may need to manually specify locations of source files and compiled class files. And also common sources can be easily lost because they are located in the different folder than JVM platform sources. To address all these issues, we now present you a Kover, an all-in-one solution for Kotlin code coverage. I want you to try. So Kover is essentially a Gradle plugin, which works with Kotlin JVM projects as well as Kotlin multi-platform projects, of course their JVM part. It produces reports in format compatible with JaCoCo, and it also offers you pluggable agents. So let's cover these features in more detail. As I said, Kover is extremely easy to configure. Because this is a Gradle plugin, you just need to specify it in your plugins block, in your build script. And it would work out of the box with Kotlin JVM projects and JVM part of Kotlin multi-platform projects. Kover also offers you an agent to select. Essentially, Kover is just a Gradle plugin, and it uses existing coverage agents to instrument classes and collect coverage. So currently, Kover can work with two agents, an IntelliJ agent and a JaCoCo agent. So you can specify their versions explicitly, but by default, the default versions are used, so this configuration block is not mandatory. So to select which agent you want to use, just configure your test task with the Kover task extension. So you can launch different test tasks with different agents you like. Also, Kover can help you with integration with third-party tools. Well, if you use a JaCoCo agent, of course you will get a JaCoCo report. But even if you use IntelliJ ID agent, Kover can transform its report into the well-known XML format that is compatible with JaCoCo. So you can take this XML file and then use it with any third-party tool for code coverage analysis you like codecav.io, or use it in GitHub Actions or in your internal analyzer. So if you want to try Kover, just follow these simple steps. First, you need to apply the plugin, as I said, either in the Gradle plugins block, or if you prefer the old Gradle syntax, just add Kover to your build script class path dependencies and apply it in the old way. And then you can just run tests and enjoy, because Kover automatically configures itself so it collects coverage on a regular test task. So when you run your tests, the coverage report will be prepared for you and put in the special folder inside the build directory. Important experimentality note is that the Kover plugin is now an experimental prototype, meaning that the configuration flags I presented you may be changed in future or even by the time this video is released. Of course, we are going to enrich and improve the functionality of Kover, and we welcome every bit of your feedback, whether it is a bug report or a feature request. We want to hear your thoughts out. Thank you very much. If you want to try Kover or leave your feedback, please visit our repository at GitHub and have fun with Kotlin.